All right, we're going to start from slide 23. There was a warm-up activity. There was kind of a little group activity based on predictions and demonstrating what an exponential model looks like. But we're going to see that straight in the graphs. So let's cut to the chase. Two things we're going to do today. We're going to look at graphing and recognizing key components, and we're also going to apply transformations like we did quadratics in the previous lesson. So they're the two things that we're looking at today. And let's get straight on to the first one. Whoops, that first one's supposed to say properties. I'll need to fix that. So we looked at a couple of graphs this year. We've certainly looked at linear, which just means straight line. And you can see the word line in there. We looked at quadratic, which is that U shape, or it could be an upside down U shape, that parabola shape, the curve. But there is a third shape that also has a curve, which is this exponential function as well. And that's the one we're going to be looking at in this last unit. Now, there is a little IXL activity you could try if you want to make sure you can tell the difference. I think it's pretty clear. You can see that one's straight and one's curved on here. So linear and exponential are kind of clear to tell the difference between the two. How do you know that this doesn't go like this, makes the U shape and is quadratic? We'll talk about that part in a little bit. So the form for an exponential graph is this: y equals a and then b to the power of x. So a is just a number, b is also a number, and then x is just going to be whatever that value is. So there's your linear, there's your quadratic, and now we're looking at the exponential, which is the third one. Now, there are a couple of little activities that you can do to slide this around. So the number at the start, let's see what that actually does. And if you notice when it's on 2, you can see how it goes through 2 on the x-axis. On the y-axis. 3 goes through 3 on the y-axis, and so on. So the starting number is actually where it passes through on the y-axis. And there was a chance to write something about that. And then this is what happens when you move B around and keep A fixed. Now, this one's not quite so easy to do. So we're not going to focus on this one because this is just going to be the starting number. So let's look at what happens. So notice the y-intercept is not changing, but notice this value is. So when it's at 3, I have 3 here. When it's at 4, it's at 4. When it's at 5, it's at 5. So that second number there is actually showing you the multiplying factor. So if we look at the y values here, this one's 1, this one's 5. What I've done here is I've times it by 5, and these two things are next to each other, notice as well. Now, if I move this back a little bit to 2, this is a little easier to see here. So we can see this 0.12, but notice it also passes through the 0.24. 2 times 2 being 4. Notice it also passes through 3, 8. 4 times 2 is 8. So this is a multiplying pattern. If I was to change this to 3, then you can see it goes through 1, 3, but you would also notice it goes through 2, 9 as well. 3 times 3 being 9. So that's the kind of difference between the quadratic and the exponential. The quadratic is just going to be things that are squared. That's not going to be necessarily true for this one. Now, there are a couple of questions. What happens to the y value as the x value gets closer to negative 10? So let's go back for a second. So negative 10 over here. That kind of looks like it's 0. Now, if you click on this, you'll see that it's not 0, but it's very, very close to 0. And as I move further down the line, it says that it's 0. It's actually not, but it's getting smaller and smaller and smaller for sure. And what's happening as we get closer and closer to 4? Well, it depends on what value you have. 4 is actually off the screen for this one, and this is just at 3. Perhaps if I move it back to 2, we can just about see it up here. It looks like it's 16. If I was to change this to 3, by the time I get to this graph 4, it's going to be a really big number. And if I change this to 5, it's going to be an even bigger number. So this is something where the numbers really increase really quickly. And I think I just clicked on the wrong button there. Whoops. So let me click back so we can get to that graph. There we go. So that's what the effect will have. The y value will get bigger and bigger as the x value gets further and further to the right. So this is the graph of 3 times 2 to the x, and it says look at the y values for negative values. So yeah, once again, you can see that these numbers are getting really, really small here. 0.004. Now, I can actually zoom in because it looks like it's touching 0. But as I zoom in, what I'm hoping you can notice is, see, it's not touching 0 now, you can see. And if I zoom in even more, you can see that it's not actually touching 0. It's getting closer and closer. So as I'm getting towards 9, it looks like it's touching 0. But then if I zoom in again, once again, you can see that it's not actually touching 0 at all. So it gets very, very close to 0, but it doesn't actually get to 0 at all. And whoops, that's what it asks you to do this one. Does it touch the x-axis? It does not, but it certainly looks like it. So now, if you look at, when we just looked at this part of the graph, we thought it might have been quadratic, but you can see here, this is almost a straight line at this point. It's very, very close to zero. That would be the main difference for me between the exponential and the quadratic, just by physically looking at the graph. You're going to get that part where it starts off really slow, but then it's going to start curving up really quickly afterwards and much steeper than your general quadratic shape. So the number at the start here, that told you what the y-intercept was. And B, the base, was showing you how quickly the graph is getting steeper and steeper, depending on what number you're choosing for this one. Now, some of these activities now, as we're towards the end of the unit, this is or towards the end of the course, this is going back really implying the same skills we learned, but for different questions. So for this question here, we're trying to find the rule for y equals 2 to the power of x. So I'm going to type in y equals 2 to the power of x plus 1. And it's not always easy to see in here. I can certainly see 0, 2. And I could use the trace function on here, but it's much easier if you click the wheel and then click on the table. Now, I don't want anything that's decimals here, so I'm going to kind of scroll through those. So 1, 3, I can see is another point. And then I can also see 2, 5 is an extra point as well. So that's a good way of finding out points that lie on. Using the table function will quickly get you to the answer that you're looking for. And then there's one for you to try as well, and it will tell you if you got the right answer or not. But use that same method. Now we're on to transformations. That's what we were supposed to see earlier. So when we did quadratics, there's basically three essential transformations that we look at. One is like the slide, the moving up and down, which we must use these words out. We've got to say vertical translation, and then we have to say up or down. You can't just say it moves up 3 places. You've got to say vertical translation, up 3 squares, or up 3 units, whichever one you prefer. So for this graph here, f of x is the original graph. So black is the x squared, and then orange is the transformation graph. So the lines on here are just to show you that for every point, hopefully you can see the orange graph is 2 spaces lower, or 2 units lower than the black graph. And for that reason, we will put a -2 at the end of our question. So we're comparing the original function, and then anything at the end is what moves it up or down as we're working through our question. And then the other transformation is the stretch. It much better demonstrated when I had a rubber band, but I don't have that right now. It kind of looks like it's being squashed in, but what's really happening is it's being stretched upwards. So on this one here, it kind of looks like the orange one is inside the black one because it's been squashed in. But what really happens is it's been stretched outwards. So as we look at some values on here, you can see this is at height 4, but this is at height 8. So therefore, it's twice as big as the original one. And that works for all these points. Like you might first think when you look at this, it moves up 1 place. But when you check corresponding points over here, you can see that it doesn't move up 1 place. It moves up much more. And for that reason, that might tell you that this is a multiplication. So 1 times 2, 2. 4 times 2, 8. And for that reason, this would be 2f of x. So a number at the start will actually tell you what it actually looks like. Now, for people who are prepared to type these things in, you can actually check all your answers anyway. So there's the graph of x squared, and we think that the graph is 2f of x. And if we type in 2f of x, you can see it's, well, in this color it's blue, but you can once again see that it's inside this curve. So it looks like it's been squashed in this way, but what's really happened is it's been stretched that way, vertically. And the opposite of the stretch is the compression. So it kind of looks like it's been gone outwards, but what really happened is it's been squashed down, which forces it outwards. So on this one here, notice the black dot is at 4, the orange dot is at 2. That's half the value. The black dot is at 1, the orange dot is at 1/2. Once again, half the value. And for that reason, we'd say that this is a vertical compression. So bigger than 1, we're going to say stretch. Between 0 and 1, we're going to say compression. And for this one, vertical compression. But once again, the number at the start tells you whether it's going to be that stretch or whether it's going to be that compression. The number at the end tells you how much you move the graph up or how much you move the graph down. And the last one is the vertical, is the reflection in the x-axis. So when we have a negative function, so if we have f of x equals x squared, negative f of x would just be negative x squared. But notice each point here, this one's at 1, moves down to -1. This one's at 4, this one moves down to -4. So sometimes in word problems, they won't give you necessarily the picture. Now you can type this in like we showed on the last question. You can type this in and this in and look visually to see what happens. What we prefer to do is to do it this way. So if it's at the end, I know that's the vertical translation. As it's positive, I know that means up. So I can pick the vertical translation on 3 places. If you're not sure, just type it in and check the picture. Once again, this time this has the number at the start, so I know that's the vertical stretch, particularly as it's a number bigger than 1. So I can click vertical stretch, scale factor 3. And on the last one, this time I'm doing negative f of x, so I know negative turns the graph upside down, which I know is a reflection over the x-axis, and they're the 3 that they can ask you. But this one, just to show you, this will be really easy to check if we weren't sure what this one was. So 4 to the power of x. And then I'm just going to type in k of x equals negative f of x. And you can see that it's an upside down version of this graph, or it's just been reflected over the x-axis if you prefer. And this is, first of all, the review from the quadratics question. So f of x plus 4, with it being at the end, I know that moves the graph up 4 places. So if I was looking at this point here, for example, instead of being at 27 on the y value, it would move up to 31. Now, I don't see 331 as one of my answers, so let's see what happens if I add 3 onto this. That would be 0, 3, which I don't see. That would be 6, which I don't see either. Oh, sorry, add 4. I apologize. 0 add 4 would be 4. 3 add 4 would be 7. And for that reason, that's going to be the answer to this question. If it had been this point here, it would have been 216, and this point would be 331. So really just simple math, but it's knowing what each of these operations do. Now we can do the same thing with the exponential curve as well. So as long as I know what the thing at the end is, I know that's the vertical translation up and down. I'm adding 4 onto the y values. This would be 0, 5, which is not an option. This would be 1, 6, which is not an option. This would be 2, 8, which is an option. And this would be 3, 12 if I was to add 4 just onto the y value. Number at the start, that's going to be the vertical stretch. That's going to times the y value by this number. So I would do 1 times 2, which is 2. 0, 2 is not an answer. 2 times 2 is 4. I can see that that is one of the answers. 4 times 2 is 8, so 2, 8 would be another answer. And 8 times 2 is 16, but 3, 16 is also not one of the answer choices for this question. This one's at the end of the question, so I know this one's it's a vertical translation, but this time it's going to move it down 1 place. So the y values are all going to be 1 less. So instead of 0, 1, 1 take away 1 is 0. Oh, I found it first time this time. If it was the 1 for 1, it would be 1, 1, because 2 take away 1 is 1. 2, 3, and 3, 7, and none of those were answer choices this time. And 4 f of x, so I'm times in the y values by 4. So this is that vertical stretch. So each y value times by 4. 1 times 4 is 4. Do not see 1, 4. 3 times 4 is 12. I do see that one there. 9 times 4 is 36, but I don't see an answer that says 336. So I'm going to ignore that answer. 1 half x, so I got a half the y value. So half of 2 is 1. And I think I just found my answer for this question. 2, 4 would also be an answer for this question because 8 divided by 2 is 4. There are answers that you can find within the Desmos activity if you need to check. And there are some recommendations for IXL exercises. And some of these will be part of the assignment. Just trying to figure out exactly how many to give at this point. And that was our objectives today. Graph and recognize key components of an exponential function. So really it's the y-intercept, and then it's also kind of how steep the graph gets, how much stretch it has on it, but also practicing those transformations that we looked at with linears, quadratics, but now we're looking at with exponential functions as well. And that concludes the video for this lesson.